Today we're going to continue with section 7.6, linear programming. Linear programming is a very easy concept dealing mostly with business applications. And linear programming, it's also called linear optimization. It's a method to achieve the best outcome in a mathematical model. We either want to be able to find the minimum or the maximum value of a quantity. It probably, most likely, will be the cost, the profit, how much you sell, is what we're going to be looking for. Optimal solution of a linear programming problem. If a linear programming problem has a solution, it must occur at a vertex of a set of feasible solutions. So whenever we're looking for the maximum or minimum, we are going to be looking at the vertices of the system of inequalities. But let's go through the first example. And the first two examples are going to be a little more abstract in what we are looking for. But once we get to the third example, or word problem, you'll make a lot more sense. So let's go through the first example. It says, find the maximum value of the following equation. And we call this the objective function. Most likely, this will deal with price, cost, or profit. We are also going to be given a set of inequalities, and that is what we call the constraints, the restrictions that we have. So therefore, we are going to be graphing. And just like on the last application for 7.5, we are going to be restricting our inequalities to be on the first quadrant, just positive values, since we are dealing with a word problem and an application. So in this case, you guys have some graphs in case you don't have graph paper. I do have graph paper, so I'm just going to make a first quadrant graph. And I just need about 8 spaces to the right and 8 spaces above. And I need to be able to graph each of the equations. Remember that you do need to show me some of the work. So let's deal with the first graph. The first graph is x is greater or equal to 0. So that means that it's going to cross the x-axis. It's going to be a vertical line at 0. So it'll be right here. And I need to be able to decide which side to shade, whether I need to shade the left or the right. So therefore, I'm going to test a point. I'm going to test a point that's now on the line. So in this case, I cannot test 0, 0. I'm going to test 1, 1. It's a very quick process, so make sure that you show me this on your homework. Your x value is 1, it's greater or equal to 0. That is true. So therefore, I'm going to shade 0, 0. And I'm going to use my pencil and do it nice and light shading, because I'm going to have to go back and erase. Some of you guys are waiting until the very end to shade, which is fine. Just be careful. I'm going to graph the second equation. Y is greater or equal to 0. That means it's going to cross the y-axis at 0. That means there's going to be a horizontal line at 0. And I need to decide which side to shade. So therefore, I'm going to test not 0, 0, because the line is going through 0, 0. So I'm going to test once again 1, 1. Instead of the y will be 1 is greater or equal to 0. Once again, that's also true. So therefore, I need to shade above. I'm going to go and graph the third equation, which is x plus 2y is less than or equal to 4. And To graph them, I'll leave the y by itself, place into slope-intercept form. 2y less or equal to negative x plus 4. Divide by 2. And now I can graph it. Y-intercept is 2. My slope is negative 1/2, so I'm going to go down 1 into the right 2, down 1 into the right 2, down 1 to the right 2. So therefore my graph will be also solid. I'm going to test a point. Now when I test a point, I prefer to test it on the original inequality. And I can test 0, 0. Or you can test it on this one if you want. Most likely I'm going to test it on this one. 0 plus 2 times 0 less than or equal to 4. That'll be 0 is less than or equal to 4. That is a true statement as well. So therefore my shade towards the 0, 0. So notice right now our solutions, without graphing the fourth one, right now we have that triangle as a set of solutions. So therefore let me go and graph the last one. X minus y less than or equal to 1. Negative y less than or equal to negative x plus 1. And whenever you divide by a negative number, don't forget to flip the inequality. So therefore y is greater or equal to positive x minus 1. Y-intercept is negative 1. My slope is positive 1 over 1. And there'll be a solid once again. Oh, there you go. Negative 1 up onto the right. No, that's correct. Ignore my other points. And I need to decide which side to shade. So I'm going to test a point. In this case, I can still test 0, 0, since it's now on the line. And I want to test it into the original problem. So it'll be 0 minus 0 less than or equal to 1. 0 less than or equal to 1. That'll be true. So therefore, I'm going to go and shade towards 0, 0. If you notice, the set of solutions, the set of feasible solutions will be in this section here. So those are all the solutions, and because it's equal to throughout, that means that all the solutions can also be on the line. We're trying to find our maximum or a minimum of solutions. Let me erase everything else. So the only thing that I want to keep shaded, you can highlight it as well, once you know for sure that's the section that you want to keep. Once I find my solution, since I want to find the maximum or minimum, according to our definition of optimal solution, it must occur at a vertex. And the book has a nice explanation for it if you want to kind of scan through it, the reason why. For now, for purposes, we're just going to check each of the solutions or each of the vertices. So this will be 0, 0. This will be 1, 0, 2, 1, and 0, 2. So we're going to have to test each of those four vertices into our objective function. So let's go through the process. So at 0, 0, we are going to use our objective function, which is z is equal to 3x plus 2y. And we're going to substitute the value of x and the value of y. So therefore, z is equal to 3x plus 2y. The value of x is 0, and the value of y is 0. So therefore, this will be 0. And now we need to be able to test each of those points to be able to obtain our maximum or minimum value. Our next one will be 1, 0, and I'm going to do the same thing at 2, 1, and the last one will be 0, 2. I'm going to go and plug it into my objective function to determine the maximum or minimum value or cost. 1, 0, 2, 1, 0, 2. I'm going to evaluate each one, so it gives me 3 plus 0 is 3, 6 plus 2 is 8, and 0 plus 4 is 4. So from here you can see that 0 will be our minimum value and 8 will be our maximum value. So we just need to write out the answer. Minimum value of 0 occurs when x is 0 and y is also 0. Or maximum value of 8 occurs when x is equal to 2 and y is equal to 1. So therefore we find our minimum and maximum value. Minimal should be minimum. So let's continue to example number 4. We'll come back to the examples that are on the textbook so we can go for a few other concepts. So go through the same process. This is your objective function. And these are your constraints. Remember though, we are going to be dealing with real life problems, business problems. So you want to be able to just have your first quadrant, most likely. So just make sure you have about 8 spaces above and 8 spaces to the right. Or you can use one of the graphs that I provided for you. So go and pause it. You guys need to work through the process and then we can talk about our solutions. We can compare our answers. Go and pause it. Great. So therefore, once you have it done, you should end up with the following. Once you graph all 3 of them, you should be having this region, and notice that this section is unbounded. And we talked about that in the last section. Now, one of the things that you'll notice that whenever you have an unbounded section, you are going to be able to find a minimum, but because it's not bounded above, you're not going to be able to find a maximum. But we'll be able to find a minimum value. So you graph each one. Then once you have it, we are going to use our objective function to determine the value at each of the vertices. So notice that in this case, my minimum value occurs at not 12, but at 10. That'll be our minimum value. And make sure to write down that there is no maximum value since the graph is unbounded, but the minimum value is 10 when the x value is 2 and the y value is 1. So if you need time, go and pause it before we go into the next problem, which will be a word problem. Great. Let's continue to the word problem that we have for example number 7. Or example number 5, excuse me. So I'll give you guys 2 or 3 minutes to read through this. Go ahead and highlight the key things. Go ahead and process it. It's going to be very similar to the problems that we did on 7.5. Remember, one of the things that you have to keep in mind is that your cost will be your objective function most of the time. Go ahead and pause it. Great. A candy manufacturer wants to maximize the profit of 2 types of boxed chocolates. A box of chocolate covered creams yields a profit of $1 per box. So covered creams, let's say creams yields a profit of $1.50 per box. And a box of chocolate covered nuts yields a profit of $2 per box. Market tests and available resources have indicated the following constraints. So first, let's go and write our objective function. We're going to call that z is equal to, so we need to be able to set some variables for the creams versus the nuts. So x will be the chocolate covered creams and y will be our chocolate covered nuts. So creams yield profit of $1.50 per box will be 1.50 x plus nuts yields a profit of $2 per box, 2.00 y. And notice that on this word problem they have the constraints separate, which makes it a little easier. For constraints, the combined production level should not exceed 1,200 boxes. So therefore the number of cream boxes plus the number of nuts should not exceed 1,200. So it means that it should be less than or equal to. The demand for a box of chocolate covered nuts is no more than half the demand of box of chocolate covered creams. So the demand of box of chocolate covered nuts are the y, is no more than 1/2 the demand of boxes of chocolate covered creams, which is x. So that means that it has to be no more, so it has to be less than or equal to. And see if you can write an inequality for problem number 3. Once you write that inequality, go ahead and get your Chromebook, and we're going to be doing this on the Chromebook, especially because the numbers are a little large, and the book does ask you guys to use graphing utilities for some of the problems. Everybody's writing constraint number 3. Once you have it, get a Chromebook, and then we can check our answers. So now this should be your equation. The production level for chocolate covered creams should be less than or equal to 600 plus 3 times the production for chocolate covered nuts. Okay. At this point, everybody should have the Chromebooks. If not, go and pause it. Everybody should be typing the 3 inequalities into the Chromebook, and then we can check our progress. Excellent. So let me go into we have decimals. I'm going to type in the first one, x plus y is less than or equal to. Notice that as soon as I press the equal sign, it gives me the inequalities. Then I'll type in the second one, y is less than or equal to 1/2 x. And then the last one will be x is less than or equal to 600 plus 3y. And you guys can see that you guys cannot see everything on the graph. So one of the things that you want to make sure is that you use your zoom out to be able to zoom out. Notice that we're going to have to reach 1200. And you can do that. And now you can see it. Other thing that you guys can do, you can start playing around with your domain and range for the x-axis and y-axis. So sometimes I know that I'm just working with the first quadrant, so I usually just type in negative 100, and I don't need to reach 1200, so I just go maybe 1300. And for my x-axis, I'm going to do the same thing. Negative 100. At this point, you should be able to see to 1200. Or 1300. There you go. And you guys can see that it's easier to be able to have your domain. Otherwise, you can zoom in and out. But having to play around with your domain and your range of your graph makes it a lot easier. Now, you can go and copy this on your notes, or you can go back and print it later on. For purposes, we're going to copy it down. I'm going to go and select the x and y axis, or excuse me, all the vertices are here. You guys can see that that's a section. And let me try once again. There you go. And I'm going to copy that on my note. So if you don't have a printer at home, you can just do a very quick diagram. So let me go and copy it down from my screen. And I just need the first quadrant, so therefore I'm going to go and make an x and y axis. I'm going to go by 100, so it'll be 100, 200, 300, 400, 500, 600, and 800. I just need the graph itself, so I don't need to go over 1200 all the way through. I'm going to do the same thing for my x-axis, 200, 400, 600, 800, and so on. 1000 and 12,000. My vertex is at 0, 0, at 800 and 400, at 600, and at 1050, 1050, and 150. I'm going to enclose my regions. Remember that you can also save those graphs on decimals if you sign in. And then just go to the computer lab and open them up again, and you'll have it ready to be printed. So therefore, this will be my feasible solutions. Let me go and label my vertices. 800, 400, 0, 0. This will be 1050 and 150. And this will be 600, 0. And now I'm going to use my objective function to determine which of those will be my maximum, since I want to be able to maximize the profits. Now, if you notice, most likely our maximum will come from here or here. And 0, 0 will be our minimum. But let's go through the process. My objective function is z equal to 1.5x plus 2y. So at point 0, 0, I'll be z is equal to 1.5 times 0 plus 2 times 0. And that'll give us 0. At 800 and 400, Z is equal to 1.5 times 800 plus 2 times 400, which is 2000. Uh, 1050 and 150, that'll be 1.5. That'll be 1875. And the last one will be the 600 and 0. My Z value, $600 will be 600 plus 300 will be 900. So from there, you can tell, just like we said, our maximum will become from those two. So our maximum value or maximum profit our maximum profit of $2,000 will occur at creams equal to, that'll be our X, will be 800, and nuts will be equal to 400 manufacturing. So you guys have the homework on the left. Remember that if it's a word problem, I do need to be able to see a full description of your answer. And whenever it's asking you to do a graphing utility, you can either copy and paste and then print your graphs, or you can just do a very quick graph. It doesn't take long. Make sure that you do your homework on graph paper, and I'll see you guys next time.